Well, hello.
Hey,
How you
happy
doing?
Tuesday, are we meant to say, or Thursday?
Friday.
Friday.
Friday is the day. And I
Just
think the
trying to
intro
do a
music
Nick
is
on it. And Nick.
yeah,
The other Nick,
yeah,
sorry.
exactly.
Yeah,
All right. Well,
legit
yeah.
indeed. Happy Friday.
Sorry. I got a little weird inception because I was waiting in YouTube on our channel for another because I grabbed the link and I started hearing Inception. And all right, yes, happy Friday, happy Tuesday, Wednesday, I don't know, whatever day it is, but we're here. Obviously, Keith's on the show with us today. Nikki is traveling. He may pop in, he may not. He's a busy man. He travels the world these days, so if he comes in, we can hang out. If not, we'll continue on. But I guess the preface for this show, this is now kind of a three-parter where we talked about, first kind of debugging LLMs and some of the practices and policies to get LLMs into your organization and approved in that jazz. And we kind of deep dived on GPT OSS last week. We saw some strange performance issues between Ollama and vLLM that we didn't quite expect. So I kind of went down a rabbit hole, and Keith was actually kind of wondering some of the same things as he was watching last week. So I thought it'd be good to bring Keith on where we kind of really deep dive and have this Ollama versus vLLM performance kind of debate and showdown, and kind of deep dive into some of that. So that's the show for this week. That's the preface. I've done a bunch of testing and scripts. I've kind of done some experimentations and research, and I think Keith has done some things as well. So we can talk about it. And I'm still currently running some performance tests. So if you hear a slight screaming whine behind the scenes, that's one of the UPSs in Kuhn Labs having a little fit when a lot of GPUs are
It's your
at
wife
full
seeing
capacity.
The bill,
Yeah, yeah. Well, I have to run these tests during the day when it's only me, and I can't run them overnight and have everyone complain about why they can't sleep. So hey, it is what it is, right?
Yeah. So yeah, it was a bit of fun. I was running some tests as well, but my test rig went down. So
oh no,
I had fun, and it's the usual thing. If it's not DNS, it's NTP, and it was NTP.
Yes.
Minefield, everything, drift was fine and everything, but one box was complaining, which caused my test rig to go down. So that was a fun late night getting that all back up. But yeah, lessons learned. Practice what you preach, document your config, committed to a repo. So seemed to be on one config was a manual change, and of course when I repaved my environment, it missed it because it was a manual change. So lesson learned.
Yeah, we all learn, but you'll remember next time to always double, triple, quadruple check your NTP settings, right? And I guess that's the one error that is the most ambiguous. If you have just strange networking problems, it's hard to debug sometimes, right? I actually went through a similar issue. I've been doing a significant network upgrade in Kuhn Labs, and I migrated. I had a physical pfSense appliance that I was doing DNS, NTP, things of that nature, and I had a virtual appliance as well. But I wanted to get rid of that old physical box and just have multiple virtual appliances. And it's just a lot of weird things happening when I was trying to migrate that over, and VLAN configs and things, and it took me a couple of tries, but I just originally tried to just like copy the switch over and change the port, and then everything just went down, and it was just sadness. And luckily the core infrastructure stayed online because it just failed over to the virtual pfSense box, but a lot of my home networking took a beating because it was trying to hardwire into that first DNS server. So DNS and NTP kids, they will break all the things. So without further ado, any banter, Keith? Any other besides your 24-hour network woes?
No, playing the GenAI tile has a new release, and it has the latest bits for vLLM and Ollama, so that's cool. We get to play with newer bits. Well, we get to play with it. Customers get to use it. That's
that's true.
I'd say this is for playing. And just feedback on the script. More people are using it, so I've just finished writing a new function in it for offline model storage, because not everyone has the benefit of open access. So for internet environments, I've set up a thing now so we can store models offline and pull from that. So
very cool. Very cool. Well, yeah, that's a big deal. You want to, yeah, that's always the getting the model approved and then storing it is a good thing to get through. So we appreciate you continuing to update
and it's an interesting
your magic.
time, even in that model storage. There's many people doing it now. Like you see it up in Docker, you see GitHub, but there's no true standard yet. So that's going to be an interesting space. Like anything new, Betamax, VHS, there's back to what standard will prevail and different ways of doing it. So a bit of discovery there, going around, seeing what they're doing, what are they using under the covers. So I could see, could I recreate it and have something that will work for everything? But yeah, it's interesting times. But it's exciting, but it's also hard to keep up. It's a very fast pace, the rate of change at the moment in this space.
Oh yeah, for sure. Hard to keep up, definitely. So yeah, I guess without further ado, I'll bring my screen up and let's add the stage. And I'm actually running a test right now, so we'll see some things happening. But when I first started out earlier this week, I know there are a lot of like benchmarking tools out there. There's a couple, like I think one's like vLLM Perf. It's like part of the Ray project. There's something part of vLLM called like guided LLM. I tried a couple of those. I was either having issues with the Python dependencies working on my machine or just like not firing up. One of them I tried, like for some reason wasn't like didn't want off to the AI server on Tanzu Platform. Like it didn't, like I was following the OpenAI compatible API path, and for some reason just like wasn't taking my API key, and I didn't understand what was happening. And I was kind of futzing around with a couple of different tooling, just because it's just like, yeah, this is a problem, or this is an area that people have solved. But I didn't quite find anything that fit the bill, and I definitely didn't find anything that really didn't require a bunch of dependencies getting pulled down, like, install Python and install these packages and do all these things. So I was like, well, how about I just, write something up? And I was using my good friend, the AI servers, Gen AI Tile. And, luckily I have a lot of hardware. So I had the Qwen 3 coder model wired up. So I just went into Klein and said like, hey, and I guess I can even bring that up too. We can even see some of the, let's see here, TPS tester probably. I'll load that up as well. And then if I get that prompt, where'd that VS Code session go?
And did you serve it via Ollama or vLLM?
So the Qwen model was on Ollama and working out pretty nicely. Oh, it's right here. That's why I can't see it. So I'll bring this up and let's see if Klein still has my first like. All right, so it didn't have the first batch because I started a new task, but I started out here like, write me a script that can measure, tokens per second when chatting with an OpenAI compatible API. And 7.9 million tokens later, I got something going. And then I had another task where I modified it to talk with, modify this script and then use a random prompt file that I generated as well. So that's another like 1.2 million tokens as well. And ignore the cost model there because I was kind of futzing around with a few things there. But easily, with just a simple project, you can see where some of this agentic coding or vibe coding per se could really, at scale, cost organizations a lot of money. So another interesting kind of ROI story around having your own private AI models and a way to easily vend them to your developers via Tanzu Platform. So I'll continue to live this vibe coding lifestyle and keep building some projects because I think I'm fully converted now after this past week. But essentially, though, as you can see, it's actually running right now where I've been running this for many instances now, where I'm trying to fill out this data chart I've been making, but I'm using the random version generator, where here I started up 8 copies or eight instances of it to simulate 8 users, and they have iterations. So they're going to ask 10 questions in a row, and they're pulling randomly from a prompt, a big set of prompts that I had an AI write for me. And it's just, constantly asking questions back and forth. And I can pull that up really quickly here. So I have a bunch of random prompts. So maybe,
I suppose for those who haven't followed along or new to the series,
mm-hmm.
welcome as well, of course.
Yes.
Ollama vLLM. Ollama it's just really quick to get started, but actually vLLM is quick as well. But I suppose vLLM is there's more knobs and switches. Ollama is it's like, think of it as Docker, literally just Docker pull, Docker run, and you can run it anywhere. Like you can run it on Intel, you can run on Apple Silicon, or like it's just so quick and easy. Like that box, that's my gaming rig, but there's a 3090 in there, so I harness the energy of a 3090, 24 gigs of memory in that, so you can run Ollama quickly and just serve off that, or then in my server, my work server, I have another one, but it's just, Ollama definitely brilliant for just discovery, proof of concept, just get up and running, just to do some experimentation.
And to that point, again, some of the precipice, again, as I was kind of hinting at earlier, when we were doing our testing last week, the Ollama model on GPUs was actually much more performant on a single user flow than we expected. And I expected the vLLM model to perform, pretty fast as well. And it was like noticeably slower, like on our Tanzu chat app. And that's kind of where my brain broke a little bit last week, because I just expected the vLLM model to just, blow it out of the water, so to speak. But it didn't quite do that per se. So that's where we are here. And now I'm running another concurrent test on vLLM, but hence this, I'll bring up some of the data I've seen. And I've got a little bit of a chart here, but I'll make this full screen just because people can read it.
On paper, we'll see what the data shows, but on paper, it's the concurrency. That's where it should scream ahead. Let's see what the data shows, though.
Yeah. So if we look at, I have Ollama and vLLM data in different data charts here, and hopefully you can read this here. But if we look at our first row, right, and I'm measuring the tokens, number of users with number of iterations per user. So we're just starting out one user with 10 iterations. So it's gonna run one copy of that job, and it's gonna pull 10 random prompts and ask 10 random, really random questions to the LLM, because at first it was just like, say hello world, and it was all really fast, because the LLM was just getting the same question over and over again, right? So that's not quite real world example. And response time is relatively low. Now it wasn't a streaming call, so it's like the total time that it's responding back, tokens processed, and the total time we can ignore, because it's just aggregating all the. It's not I shouldn't even have this column. It was something I was recording, but it doesn't really matter, because it's just saying, hey, you can just see it scales up higher and higher and higher, because it's just that the script is just adding all the response times from all the different jobs and aggregating together, which doesn't really mean anything, but in the total process token. So great, great response time. But as we scale down, right, we're starting to see really, really not great numbers here. And I have a chart here where maybe I'll zoom out a little bit so you can see it. That first user is running pretty well. 80 some tokens or 70 some tokens per second is a very it's faster than a human can read, right? So you're going to be really good job. So 2 users coming down in here. We're still above 20 or close to 43. We're starting to come down, but as more users get added, that tokens per second is dramatically dropping, which is a problem, right? In I guess a server, web service type environment, where we're hosting these models, and you potentially want to throw a bunch of users at it. So that's something to keep in mind. So that's kind of what we expected. It's just that I did not expect this huge performance delta between the, the first, sub user sets of the first Ollama model versus vLLM. And if we look at that data too, let's look at this average response time, right? So the response time's creeping up very fast, right? So even at 10 users, it went from 27 seconds to 205 seconds. So our we're already probably starting to get timeouts per se, like things are like if we have other jobs calling this model, it's starting to back up, or you're just getting calls like the thing calling it probably hits its HTTP timeout and just drops the connection, right? So that's not great. But now let's look at the vLLM data. I haven't used the little chart converter tool yet, but we'll see the data here.
Okay, yeah.
And now
it's doing what the theory says anyway.
Yeah. So in theory, like now 25 used tokens per second is a lot slower than that first hit. And even response time is a little bit different as well, even slower, which is interesting. I'm still baffled by this. I've done some I think there's some settings I can do in vLLM. So this is on GenAI Tile version 10.25. Very little, like basically I'm using vLLM stock that comes out of the tile. Yeah. I haven't really done any. There's a lot of like knobs to I think to maybe optimize this a little bit better here, but this is just like stock, whatever vLLM's going to run up, basically just load GPT OSS and go. And like I think the only setting I did is use 90% of my GPU capacity, right?
Was this on consumer GPU, was it?
Yeah. So I have multiple quad 3090 boxes now, which obviously isn't a data center type card, but the cost per gigabyte of VRAM is still a pretty attractive cost point, and a lot of the local LLM scene uses the 3090 still. Now, as these newer cards are coming out, maybe we'll see that those cards maybe not be as go-to per se. Like I'm really eyeing the Blackwell Pro RTX 6000 that has 96 gig of VRAM, or really the Max Q variant, which is the 2U power throttle down to 300 watts as I'm blowing out my UPSs right now with 4 3090s. So I'm like, I could use some more VRAM for less power draw. That'd be great.
You never know. Christmas isn't too far away. Santa might be good.
Yeah, well, it's still like $9,000 a card, so that's still probably not going to happen anytime soon. But yeah, anyway, as we scale now, I have a little bit of data set here because I just kind of skipped ahead because I saw the trend, right? Tokens per user is pretty good here, right? Like we're consistently in the 25, 24 range as we increase user count, and response time is around the same. And now we have some variance here where like we went from 54 to 61 to 51. Well, that's because it's randomly generating questions, and some of the questions are like, what does this mean versus like tell me the theory about quantum mechanics or what. So like the prompts are random, so that means the LLM may spend more time responding to a certain prompt, so to speak. 8 and 9, I just kind of skipped. Actually, it was running 8 now, but as we continue, this is where I was like, well, I need to like start scaling higher because each run was like, well, let's go to 10, 15, 20, 35, 40. Like, where's the breaking point here? So maybe in the 100 user range, right? We're starting to see some more degradation. We're still, probably, but once you get below 20 tokens per second, maybe that's something where you want to be concerned about. But keep in mind, though, that's our tokens, max tokens per second on the box is really like 75 times 21.3 versus, if we go to that delta of the 10 user count, which I have a match for Ollama. So we're averaging, 7 tokens per user a second on Ollama at 10 users with a response time of 205 seconds, and vLLM is 24.22 tokens per second per user and response time 55 seconds. So, let's just say 240 tokens per second at 10 users versus 70 on Ollama, where that's really that throughput data is coming through. And kind of some of the kind of proving some of my theories. It's just that as you can, I guess more and more, running things in production, you probably definitely want to check out something like vLLM, because for that same amount of workload, or that same, like the hardware per se, right? You're gonna get a lot more performance out of that subset. So
it has a huge wide support, like a hardware matrix. Like even TPUs, like it's serious stuff. And it's just enterprise standard. So there's a lot of eyes on this, and it's evolving fast because it's just the performant one.
Yes, so that's a fun data point, and it's that quick summary of the high level view. Now, I haven't done a whole lot of testing on a CPU model. I kind of wanted to do that here, and I had a theory about what I could do, because another feature that we support in the AI tile is I go to this, is that we can run multiple copies of these models right behind that model endpoint. And let's see if my changelog finished. I was deploying, I just deployed a CPU model with 3 worker nodes of 20B, which is a faster model. And that was another model that kind of surprised us too, where like, hey, even on Ollama, like this is looking pretty good, right? Like the CPU performance wasn't quite terrible, but I've only done this with the vibes, right? I've never analyzed it with a tooling to get that kind of raw tokens per second view. So yeah, that looks like that deployed. So yeah, I just added a new model with GPUSS, and then another thing too to interesting to tweak here with Ollama is that this you can set the number of parallel requests. And I was doing some additional reading where somebody did a very like a white paper on some of this performance. I think they bumped this up to 32. Now that having a large context length, that means the amount of system RAM you're going to need is very high. But like I said, once they got past 32 with Ollama, it just didn't quite really make a whole lot of more sense. So that would potentially make some of those, help Ollama scale a little bit more as well. And maybe as the Ollama team continues their turbo project, where they're now hosting Ollama, and you can like pay them like $20 a month to get what they call Ollama Turbo, and like hit some of these models via their I guess cloud hosted service. Maybe they'll make more and more improvements in their engine, and we'll see better performance gains there. So that's something we could try live here now, that I just need to check out a key and update my tester, and we could see live where this goes. But let me go ahead and do that now.
And that you mentioned about that Ollama, the market is interesting as well, in terms of bit mining companies are realizing there's more money for them in leasing out their gear for high performance computing, AI. So there's a lot of companies all of a sudden, like what's one, Bitfarm, who else out there, IREN. There's a load of companies are popping up now going, yeah, we used to do this, now we're doing this, because they just see there's such a demand, and they have the gear. So
they're just renting out essentially all of their.
There's more money in renting out than mining Bitcoins.
Oh, okay, yeah. Oh, sorry, they're renting it out to AI services than Bitcoins then? Oh, I see. Oh, yeah. That's very interesting. Maybe that's my side project with all these GPUs I bought. I don't know. Anyway, just if you want to lease my GPUs, let me know. We'll set up a time lease here. But yeah, interesting. So let's see here. All right, I guess I'll bring this over to this. Is this the same profile? Let's see here. I think I can just drag this tab over. All right. You see? All right.
Yep.
All right. So I'm going to go to the marketplace, go to our trusty GenAI Tanzu Platform tile. So now this is where this new multiple worker CPU model I've deployed. I'm going to select this plan. I'm just going to call this I'm going to add it to demo space. So what I'm going to do now is I'm going to create the service. I'm going to create a service key. So this is very similar. Like if you're hooking this up to an off platform, like a client or something, that's like the same flow we use to do that. But I'm going to use this as a key to then run performance testing on. So do this, create service key. And this key will be destroyed after the show. So I'm not going to worry about hiding it or whatever. CPU test. Create. And then basically, this is great. I get this endpoint. I'm just copy and paste this off screen so I can put this in some variables. I'll close that out. And what's this model name? Oh, yeah, I think that model name was... Let's refresh. Oh, did I do a multi-mare? I think I did a sync. We'll see if this works. I forgot how I set up this plan. I forgot to check singleton, I think. Yeah, well, we'll see how this works. Not expecting to see how this to work, but we'll give it a go. All right, so
and I'm saying that's what the latest version of the tile has allowed us to use. The GPT open source one now, isn't it?
Yeah. So that's another thing too. With the latest version of the tile, we've bumped vLLM up quite some releases. So if you're like what you see with this vLLM stuff, we have the latest and greatest vLLM release out there now, and that requires it's updated all the dependencies and things to run GPT-OSS and vLLM properly, and even the tooling support and everything, which wasn't quite working last week, even on the main vLLM release. They shipped a new version and fixed all that, and then Ollama has been updated as well. However, they did release a patch right after we dropped. We are either way, whatever version, Ollama or vLLM, we kind of fully supporting GPT-OSS now.
Looked up, we're on Ollama 0.11.10 and vLLM 0.10.2.
Bear with me here. I'm just typing out a few variables here, and then once I have these, we can run it in these different tooling, and we can talk about this new tooling, this other tool that I found to do some more testing as well.
Yeah, and as we say, it's changing so fast. I know I was reading with vLLM, there's just so much more support coming and enhancements. So I know last week you talked about MOE. I always get that mixture of experts. I think that's right. Yeah, more enhancements coming to that, I remember, and just as well more hardware optimization. So there's GPUs, of course, are advancing, but to utilize those advancements as well. As we say, it's so hard to keep up. But it's interesting that it's changing so fast. Versus back in the day, we'd wait a year, 6 months, 9 months for something new. It's changing so fast, but it has to, because it's just the rate of the pace of innovation and changes of what's coming.
Well, yeah, it's not only the inferencing engine, the hardware, everything's changing. So you have the models, you have the frameworks changing, everything's all changing at once. So it's definitely been very interesting to try to keep up with, for sure. All right, so there's another tool that I found. It's called Llama LLM API benchmark, which I almost called it Llama because it kind of looked like that for a second. But that's another utility. I'll have to find the link here as well. And I'm going to try to run it here now on the CPU worker, which is we'll see. We'll see if this works out. Let's see if I copy the right variables. All right, so I'm gonna do a bunch of exports. All right, that looks
open a tiny bit, Nick. Yeah.
Oh, okay. All right, so let's do this, and then hopefully it likes this endpoint that we just grabbed. And I could have, I did not copy something. Missing an H in HTTPS. Let's try this. Clear the screen. I'm curious to see how this does. Yeah. Okay. Let me update that really quickly here. I do have a single CPU plan. I don't think it likes that plan config that I left as multi, so it should give me a new binding. But yeah, that's another thing too. We have plans that can support multiple models, so you don't have to bind a single plan to a single model. I'm just gonna hit review pending changes, apply changes. That may or may not finish before we conclude for the show today. But
and you're not on latest Intel architecture either, are you? You're
no. Yeah, so that's another thing too, is that as I was like vLLM at one point didn't support CPU only inference at all, right? And they do support that now. I haven't played with it a whole lot, but I do see even on the MOE features of like for CPU only inference that they have some things around there, and but it's like, oh, it requires AMX extension set. So as these newer hosts, a lot of people are rolling in new hosts now, especially with like the 4th or 5th gen Intel architecture. That would be something that's very interesting, I think. The Sapphire, Emerald Rapids, and I'm assuming like they have another generation after that, so I'm assuming that's like also has AMX extension set as well. That could be something that would optimize CPU inference as well. All right, so that's running. I'm gonna I guess.
And you don't have to be on latest and greatest like there. Like I have a what is it? I have a Skylake, I think, in one of the boxes, and the other one's a Broadwell. Like so, you don't have to. They're quite old architectures.
Yeah,
they work. They mightn't be as fast, but they work. So again, it's perfect for just your experimentation. You don't need latest and greatest.
All right. So that's cooking. I'll show off this other tool more in detail. And that's running now on the Ollama model. And where is this? I have another shell. So this is the Ollama model right here. So I guess I can do side by side. So I have multiple 3090 boxes, and this is Ollama. But if you look at it, interestingly enough, though, it's another thing too with Ollama here, is as we're scaling this, we're not like these GPUs. If you can tell, like an NVIDIA top, like I didn't mean to do that. They're not anywhere near fully utilized, right? We're sitting at 23, like the actual GPU percentage is not fully utilized, and the CPU, like CPUs aren't, we have a CPU core essentially assigned to each compute or each GPU and vTop, and it's not bouncing around. So that's another thing too. I'll run this on vLLM and we'll see the differences as well, where kind of maybe explain some of this concurrency as well. But yeah, essentially you kind of hit this kind of theoretical bottleneck on Ollama, and it can really only push the system so hard. And this, I guess, luckily, this testing tool suite seems to kind of match the data that I got out of this testing script that I wrote with my friend Gwen 3 Coder. So that was at least kind of validating that too, is that someone else read a utility that gets a similar response. But basically, it's just sending a bunch of random requests to the model, and I have it set with different concurrency levels, which is simulating different users. So we're at the 1, 2, 4, 8, and it's going to go up to 16, and we're getting it's going to measure the tokens per second. It's going to measure the time to first token and things like that, and show some latencies here as well.
And what was your experience of using it? Like you were using, I think it was in VS Code you were using it, was it?
Mm-hmm.
What was your experience? Did it hit it out of the box, or you realize, oh, that's not actually that right, but I know it's not right, but not exactly why, but I can probe it to know.
Mm-hmm.
What was your experience?
Yeah, so the latest version of Qwen 3 Coder it's very good, right? Okay. Considering the fact that it's a local model, it's completely air gapped in my 4 walls, so to speak. every now and then it would like, oh, like I didn't really have to like coach it too much. It would even like it would write a bunch of code and then it'll look at it and be like, oh, I made this error, and then it'll go fix it itself and things of that nature. Or there's a couple things too where um like it took some of the instructions like too literally. I was like, oh, all right, now like when I was doing like the random prompt piece, I was like, all right, now like I had some like I fired up Open Web UI and used one of these other models. I just like, hey, write me 1,000 prompts for to talk to an LLM. And Open Web UI was doing some weird formatting, and it started like appending like the app itself like a line number in front of every question. And I was just like, well, I'll just copy all this, and then I'll just have the AI itself clean up the line number. And it was starting to write a script to do all that, and I was like, oh, hold on, like stop. So I had to like kill that part, and then I was just like, how do I trim the first 5 characters of a of every line off? And I was like, oh, here's the regex to do that. And I just control find replaced, and like, all right, I'm done. Like maybe I got a little too lazy there, type of thing. And then another thing too, as part of that though, I was at that first prompt, I was just like, all right, now I want you to like parse this file and do that. And it was like I wanted it to clean up this random prop set text file, but it was like, oh, like you're already talking about this. Oh, you want me to add this into this script? I was like, oh, no. Like I see where it did there, because I was just like, I wasn't like clean direct enough. And then I was like, the next prompt, I was like, I want you to clean up this file and do this. And then I was like, oh, okay. But then it kind of ran off. It kind of over engineered the solution there per se. That's where I just canceled that piece. But that was really the only trouble of it. There's a couple of things where like it wasn't outputting the formatting right, and I had to coach it a couple of times. And then I was like, and then it's interesting where like it'll write a debug script to like test its own like because it's like following like similar logic. And I was like, well, this is bizarre, but like it was just fascinating watching it. And so it kind of got it all. And then like another thing too is that I ran this on my vLLM workers first, and then I was flipping over to Ollama, and I was having an issue, and I was like, it's like timing out. It's like what wouldn't connect. I was like, what is going on? And I was like, all right, now write it, take this script and like write a debug script and like parse the main function out, run it only one time, but add a bunch of debugging so I can figure out why this isn't working. And lo and behold, I was just like copying and pasting the value wrong, but I just couldn't quite see that from the error. And it like basically wrote this whole debugging script. And as soon as that it ran it the first time and I saw the error coming back, and I was like, oh, I'm silly. That's my bad, right? Like I didn't copy and paste something correctly. So it's fascinating to see how where these things.
It does. I suppose today it certainly highlights it's still an assistant, I would call it. It's
very much so.
It's not replaced. It's not Skynet yet. It's not going to replace us yet.
It's like guiding a toddler or something, but it maybe more than a toddler that knows how to code a lot, but you got to keep them on track, right?
I know. But it's interesting the difference between the models, even in the public ones, how I see some differences between like the Anthropic ones versus ChatGPT. They all have their use cases.
So I guess if we look at this result really quickly here, of the concurrencies, like it's like, hey, you're averaging about the token generation speed kind of caps out around, and this is only getting around 55 tokens per second across the board, no matter how many concurrent users you have. So that's kind of what we saw, in the testing, where you have that high watermark, and we never really exceeded the total tokens per second after that single user. So, generate concurrency 1, generation speed, 54.7 tokens per second. This is the throughput of tokens. And then, the min and max of time to first token is like 2.75 seconds. So like that stays the same. As you go down though, max, min and max start creeping up of like, response time. 4, that's, again, we're going up there. 8, 60 seconds to max time to first token. That's not good. 130 set, like 16, like, so that kind of, I strangely copied and pasted something there. That's kind of checks that math, and a much simpler test to run. But now let's run that on. I have another. I'll do this here live. figure this out. I just want to save this output. We can do a compare and contrast. But I can do the same thing for the vLLM situation, I think. For some reason that I hate when I do that. Bad copy paste. And this should be vLLM firing up. And we'll probably hear that UPS start screaming again.
The interest as well to run this on like your gear. I'm not gonna say your gear is not enterprise grade, but
oh yeah,
high end, new. There's some of the latest technologies, latest CPU, memory, and latest GPUs. It'd be just to really see this thing sing, you could say.
Yeah, if anybody like NVIDIA or AMD or Dell or HP you want to sponsor the Cloud Foundry Weekly show, I would gladly help test some gear in our data center. So please reach out for sponsorship opportunities. But yeah, so we're starting to see this. And another thing too is like we're not quite stressing out the vLLM GPUs yet. I mean, this is like basically identical boxes. And we're moving things, going back and forth. But this token count started to increase, right? As we add more concurrent sessions, we're getting more and more tokens per second overall. And so now we're starting to see like GPU, like more and more spikes. This blue line is the GPU utilization, so it's a lot more spiky. And like the Ollama's like
Nick, just for the audience, you probably want to bump it up a little bit.
Yeah, that's a good point. Right. Oh yeah, now it's a little bit better. So the blue line is the GPU processor per se on each of them going up and down, and we're starting to spike higher and higher and higher. I do hear that UPS alarm going off now, because if you look at I had to power cap these cards. They default to 350 each, so I have them set to 200 watts each. They're all pretty much drawing 200 watts of power right now, so that's 800 watts of power draw. Over on top of the base draw of the server. So yeah, that's over a kilowatt now on this one UPS going off. So yeah, definitely increased my power bill right now. But yeah, that's just to show like the difference of like, for some reason Ollama can only go so far, even on these GPUs. Like, can't even stress the GPUs strong enough per se. Hey Abhishek, yeah, thanks for watching. Good response time considering SSE. Yeah, I'm not 100% sure on that, but I think in general, in times of response times, you got to keep it under whatever default timeouts of whatever these proxy servers you may be hitting and things of that nature. So lower is better. I think if once you start getting like the 10-second range or above, like calls not getting not getting that first response time, that could be a problem. But yeah, so I'm not 100% sure on that question though. That'd be a good question for I would think Corby or Mark Fines if they're out there. Where's this other? All right, so I wanted to do a side-by-side, just quick side-by-side. So on the left-hand side is the vLLM, on the right-hand side is the Ollama. Let's try to make it. All right, so yeah, that's quite all right. Tab that out there. Is this readable, Keith? Do I need to zoom in more? I'm trying to zoom in as much as possible.
Yeah, no, it's okay for me, but I'm looking at a screen. Maybe not so much for people on their phone.
Yeah, well, if you're on your phone, come check us out on YouTube on your full screen desktop. But so we'll do a side by side. So concurrency 1, generation speed is slower as we expected, and even the response time is a little slower too, which is quite interesting. It's like that first hit seems slow even on vLLM, but as we scale, the generation speed seems about the same on Ollama, and time to first token starts increasing, which is like the inverse, right? So like the time to first token is decreasing and tokens per second is increasing. Seeing that as well with as we just keep jumping up through, the different currency levels, where at 16 threads, we're at like 234 tokens per second. Max time to first token was 10 seconds, which is that's starting to probably not be great, but that minimum is 8 seconds to first token. So, and if we look at that, compare and contrast, we're like night and day, right, between the two, right? Generation speed's way lower, throughput's lower, right? The prompt throughput speeds are like the, and then time to first token on Llama's 137 seconds. That's definitely causing some timeouts there. Somehow I copied and pasted that whole block. That was weird. Yeah. So that's kind of the brief synopsis of what we see here.
10x there, roughly, isn't it? Really?
Yeah. So definitely I can only imagine we have some of these enterprise cards where you have H100s or even these Blackwell Pros or A100s or L40Ss. I think you're going to see some very interesting speeds and feeds, so to speak, even just on one card, or even maybe a couple L4s or something. So that's something to keep in mind. Again, though, my setup isn't going to be something that you probably see in an enterprise data center, but maybe, I don't know, depending on who you are. These blower kit 3090s are very rare version of the 3090 that I think NVIDIA kind of didn't want to produce because it competed a lot with some of their data center cards, but because you can fit them in servers, so to speak. But hey, interesting results
as well. Like it highlights again with just Tanzu Platform. Like we can meet you wherever you are. Like you don't need latest and greatest. We can run Ollama, we can run vLLM, we can run in CPU, older generations. Like it's because you see from the headlines the unless you're a big customer and have a big checkbook, some of this gear is going to be expensive, or it's expensive, but also you're going to be waiting for this gear to arrive.
Oh yeah, for sure. Even if you can get someone to approve your check for your cluster of H100s, I guess B100s, the Blackwell version of the H100. You're still gonna be waiting for some time for sure. But I kind of plan to. I want to continue this testing and kind of maybe I'll have some blogs written up and cleaner data set. And kind of go from there, because I think that will be interesting as well. It's like what can we theoretically achieve with like CPU? Can we scale CPU workers up enough where you can get some kind of interesting concurrency? And then obviously, nothing's going to really compete with these higher end cards run on vLLM, but it's something to keep in mind for sure. And I guess that's another thing, another big caveat too, is that why you would choose one or the other is that if you do have older hardware, vLLM has deprecated a lot of hardware, or is a little bit stricter about hardware deprecation because they're so performance based. They don't want to support some of the older GPUs. So even like the T4 may be supported again, but at one point in time, the T4, even the Tesla T4, got dropped from support, which is a pretty common data center card still. I have a bunch of Tesla P40s, which are definitely on the long end of their life, but they were dropped from vLLM a long time ago, but Ollama will use them just fine. So that's another, I guess, benefit too, where having these different inference engines will kind of, like you were saying, Keith, can meet you where you are. And, GPUs are so hard to find. Let's try to use whatever we can, so to speak, and go from there. Yeah, I'm curious if that one model finished deploying, updating. I know we've got a few more minutes left on our window, 1 hour window block. Let me find this installed. Where's my apps manager here? Okay, Just trying to find where they put that apps manager. 1 second. There we go. Let's go back. Let's get a new key, or let's see if the key updated. I'm kind of curious if how that works. Services. All right, let's close. I want to delete this service. Oh, I'm gonna zoom out a little bit of this because I can't see what's going on. I'm just gonna delete this service key. Get a new instance now that we switched the plan. I should hopefully get an API format that this likes. Some of the different tooling isn't like updated enough to like auto pick up the model, and you want to. That's a case to use the singleton plan still. And that's what I think we were seeing when I ran into that. Let's create a new key.
Yeah, and if you get confused with all the, like Nick was there mentioning Blackwell, Hopper, what else? Ampere, Ada, Turing, like T4, Turing, Volta, Pascal.
Pascal,
like, of course, they're not in alphabetical order.
Oh no!
Like, why would they be in alphabetical order? So just don't think the bigger the letter, the newer. No.
Yeah, yeah. Naming hardware naming things, just like and naming anything, is always just it's a fun time. Let's just say, I guess.
Yeah, the joke always is, I'd love to be on those naming committees. How they come up with some of these things, or they're just trolling us all. I don't know.
Yeah,
but not just NVIDIA.
Yeah, it's everyone.
Yeah.
All right, so I think this working. It didn't immediately yell at me, so we'll see. Otherwise, it's just like hanging. So I don't know. Beauty of trying to do things live on air with things you're not sure if they work or not. But we'll see if that responds. Oh, it's coming back. Okay, concurrency. It's loading. The fact that it's going very slow is not great. But yeah, it's trying. Oh, I know what's happening. The models haven't loaded yet on these workers because they haven't been called yet. So
memory.
Time to first load, I think, is staging. Wow, we can try to see. I bet I can see these in vCenter easily than trying to catch into Bosch. It's estimating tokens per hour. So that's. Oh, here we go. Oh, wow. Okay. That's interesting. Let me zoom out. It did not like that. Okay. Oh, okay. Oh, well, this is interesting. Yeah. So I think we just had that first hit where all those models had to load. All right. So let me. We're gonna have to run this again because that is gonna really skew that test. If I know how to command L. Window management teaching. Well. Okay, so 7 tokens per second. I'm just going to kill this job and clean it up because it's all crazy. All right, so now we should get a better. That's my fault of. Hopefully those requests actually died when I killed that job. But yeah, so we'll let that run in the background. We'll see if it comes back. But I'll link to this performance tool. I think it's pretty clean, pretty low level, like not a whole lot of dependencies. So it kind of matched to what I wrote out there as well. So I'll link to both these tools if you're curious. But hopefully if you're watching and you're like, thinking about how things go, this is to me at least, I learned a lot this week. Seeing, I can now understand why we initially saw that better performance on Ollama versus vLLM, but as you start to scale more of like a large user format, it's probably not gonna be so efficient, so to speak. So, and yeah, that's still running. Keith, you got anything for us?
No, I suppose. Yeah, to summarize with Tanzu Platform, yeah, we can
I was trying to find one of these CPU workers. But yeah. So yeah, I guess that first hit, we're looking at 6 tokens per second, although it is starting to increase, which is interesting. So I'm curious to see how this scales with multiple workers behind it, which theoretically you could see that too as well with different Ollama, with GPUs as well. So once I get my minis forum cluster online again too, with those latest AMD chips and DDR5, it'll be interesting to compare and contrast those versus the Cascade Lake CPUs I have as well, to see what generational
you're gonna do CPU test, not like an eGPU onto it or anything?
No, yeah, just purely CPU, right? Because that's something that so I mean, that's interesting. So I'm curious if a theory, can we scale the workers out wide enough on like the Ollama CPU base to get a decent amount of performance for a model at scale? Just because so many people just have they don't have GPUs, right? But they have loads and loads of hardware, in their VCF estate with cores, right? So, but yeah, this based on this is going to take a little bit more time to run. I know we're kind of at the top of the hour. I don't know how. I know it's kind of late for you too as well, Keith. So this is probably your Friday evening, afternoon type of situation.
That's all good. This is fun too.
Yeah. And I don't know why, for some reason, it's like painting line by line on this terminal session, because before it would like update within the same line, and like the progress bar is like it's interesting. So
you're running a different type of shell?
I don't think so. I just ran it on an existing shell and reset the tokens and like reset the environment, bro. Maybe if I zoom out. Oh, that's the wrong thing. What if I just make it full? Well, I fear if I make it full screen, it's gonna go. Yeah, we got that is not optimal. It is concurrency. Yeah. Well, oh boy. I really messed this up. Can we look, it fixed itself. Look, I don't know. Okay, interesting. So concurrency 4, 19 tokens per second. So that is something interesting too. As we scale with CPU, we're starting to see more and more tokens. So that is an interesting concept. I'll have to spend a little bit more time deep diving on the CPU only situation, and definitely want to try out the vLLM as well. Try to get a vLLM that's only works with CPU or only on. We haven't tried it because for so long a time you had to have a GPU with vLLM. So that's one of the reasons why Ollama was brought into the Tanzu Platform GenAI tile, right? Because we wanted to have
on
a
your
CPU
minis, the MSA2s.
Yeah, MSA2s. Yep.
Are they the 7s or 9s or
the 9s?
Ryzen?
The 9s.
Okay.
So I suspect they'll be okay, but I guess the big question is the smaller channel count DDR5 going to outperform the multi-channel,
and will you start thermal throttling? I wonder.
Yeah. Oh, I'll have to get some fans, some extra fans, extra cooling on the minis forums before I melt them down.
Throw a few Noctura ones or whack out the 3D printer, start going experimenting and
Well, I've already got so much noise. I don't need to go quiet. I'll go full throttle on some really loud, server grade fan. But yeah. Okay, folks. Well,
Good session.
Yeah, good. Thanks for hanging out with us so long. If you're watching the show this far in and you haven't liked and subscribed to our channel, you should check it out. And the like and subscribe pillow is quite a ways away. So I see it.
Is there a
Just
cat on
virtually. No, there's no cat. Oh boy. That's no Captain Whisker Paws today, friends. I shut my door because I was getting tired of him climbing up on me, trying to sit on my face. But yeah. Maybe next week. Yeah. And with that, I guess we'll kind of sign off here. Oh, that's interesting. So on concurrency 8, I'll share my screen again. It's measuring 51 tokens per second. So I'll have to post this whole result once it finishes. 120. What is how? Oh, it dropped down. Okay. I think it's just a counting issue.
And as you say, if you share the scripts, someone may have, were good and got a nice present last Christmas from Santa, a nice big performance server or servers or cluster that they could run it against and share the results.
Yeah, for sure. And Abhishek, that's a good idea for another next show. So maybe we'll talk to Christian and see if we can get him on the show. And I definitely can't give you a deep dive of the abstraction with MCP like Christian can, but I'll try to reach out and see if we can get him lined up for a show. How about that? But without further ado, I guess we're gonna give it a call it for today. And everybody enjoy your weekends and have a good time. But any more closing thoughts, Keith, or are we ready to sign off? Yeah. All right. We'll do 3, 2, 1. CF bye.